In today's video, guys, you want to have a look what's in this box here and explore this battery, which is sitting here for far too long. And here again, I said yes to the test and review because this battery is actually available here directly in Australia from their warehouse in New South Wales. Double box. Terminal, accessory bus bars, and a USB to serial cable. 2 metal brackets for the front. Jeez, how am I supposed to get this battery out of the box here? There's no way to lift it up. Well, for this exact purpose, I bought something a while back, which I haven't used yet. This is the perfect opportunity to introduce you to... I bought a crane. Definitely supports Andy. Easy. I've got this crane for a couple of months now, and it actually folds away and is so small. You haven't seen it in the garage, right? You haven't seen it. It has a very small footprint. Yeah, and this was the cheapest option actually to lift these batteries. They are around 100 kilos. Well, this one can lift up to 250 kilos when it's fully extended. And I looked into other options like these scissor lift tables you have. You can hydraulic them up and down, but they are at least twice as expensive as this crane. So I thought, well, I give this one a go first here and see how it goes over time. And this was the maiden voyage for it. It actually worked. And a few minutes later, it is unboxed and sitting on the trolley. I built this trolley out of our kitchen board here as a cut-off of the kitchen board and used these 140 kilo casters on each side. So we can stack more batteries on top of that, which we will do. So let's have a look what we have. It is the Jaki Big Brother Orient Power or Jakiper battery. This is the 48 volt 230 ampere hour version, 11.7 kilowatt hours. And as I said, I took this review and test here because this battery is available here in Australia and usually there's nothing available. Jakiper is the only manufacturer of batteries at the moment here which has a warehouse in Australia. Everything else is coming from overseas and it takes months to get such a battery in. This one takes a week anywhere in Australia. And the first thing we notice on this battery is, wow. It's a 250 amp circuit breaker with a test button. So far we have not seen this on any other battery. So this is a very good safety feature. I like it very much. Well, honestly, the smaller Jaki with 100 ampere hours has a circuit breaker as well, where you can manually turn off the whole battery. It's mechanically disconnect. It's not only a soft button which turns off the BMS, it's a hardware button which actually physically disconnects your positive from the rest of the system. So this is already a big plus we have not seen in any other battery than the Jaki batteries. And then we've got our usual BMS power button, RS485 B and C for the communication to other batteries, RS232 to communicate with your computer and the software, and either RS485 or CAN is for the communication to your inverter or our Victron system. We've got dry contacts as in the other Jaki battery, 4 LEDs for state of charge, run, alarm. There's a second on-off switch and a reset button as well for the BMS. Okay, let's turn it on. Doing a self-check. 3 bars we have. Enter, enter, 52.6 volts. And 52.7% state of charge. So it has been tested with 238.6 ampere hours. This is what the BMS has measured when they did a discharge test. It is a 230 ampere hour battery, but measured at 238. And we also have the usual dip switch here for setting an address when you have batteries in parallel, which we will do. And this larger battery here is also using the same Pace BMS as the smaller Jaki battery we already have tested. So we should be able to parallel them and see what the communication then does. And interestingly, this battery has exactly the same width as the smaller battery, 440 millimeters from corner to corner. And you can use these brackets here on the left and right of the battery to mount it into a server rack. Okay, so this breaker is on and pushing the test button. And it goes into a middle position here. And to turn it back on, you have to push it down into the off position first and then turn it back on. You can never manually put it in the middle position. This is just the trip position. See, it either goes off or on manually, but if it trips, it goes into a middle position. So you can easily identify if someone has turned off the battery or if it has tripped because of a fault. I wish all batteries would have such a circuit breaker. Okay, I have now removed all the, I thought I did, 3 more screws at the back. Okay, removing the top lid. And look at this, how clean this looks like. I was already amazed when I opened the smaller Jaki battery, but this again is just amazing. This looks so clean and nice and perfectly built. And we can see the Pace BMS sitting down there. I can see the inductors of the current limiter, our balance cables. Oh, there's a bit of white glue here. This is like a silicon type glue. Ah, you know what? I just saw these temperature sensors here. They've got the same silicon glue attached to it as well, but they are not glued to any of the cells. They are just hovering in the air. I think it was the same in the small battery, right? And I was a bit complaining about this because they don't have exactly the thermal contact to the battery cells. They are just measuring the air above the battery cells, which is potentially fine. But man, I like these metal ducts here. It makes it very clean. You can see the flexible bus bars here going into the circuit breaker. So the circuit breaker disconnects only the positive terminal. But even if you turn off the circuit breaker, the BMS is still connected to the battery, which I like very much. And I always think the BMS should always stay with the battery, even if you isolate or disconnect your battery. Because in case of a fault, you have access to the BMS and can read all the data and can see if there's any inconsistency, any issues with the batteries. Ah, this is actually not a button, this is an LED. I just realized. It turns on green when the BMS is powered on. So to scan the QR codes, I have to actually disassemble this. Probably take this old shirt here. Hey, by the way, Average Joe, this is not one of yours. I better go on this way. Hey, I've got one at the end. Okay, let's see if we can scan it. Oh, got it already. Okay, we have the EVE Power 04Q, whatever that means. It's an LF230, 1st of November 22. As usually, I have got this battery here for a couple of months now sitting in the garage, so it's not like the cells are already a year old or so. Jingman factory, and they have produced 1095 that day. Or maybe not that day, I don't know. I don't know what this number actually means. But at least I've got 16 of them here in this battery. We've got the front compression plate here, which compresses all the cells together. And as in the small battery as well, we have the flexible bus bars across the whole battery. So even if they expand or contract a little bit here over time, these bus bars will prevent any force on the battery terminals. So that is really perfect. And I also like that they have checked and marked all the screws here in the battery. So these are all torqued down and checked and then marked with a red pen. Here's our positive cable going to the bottom of the circuit breaker. And what size do we have? A 6-gauge wire. Let me look this up, what it is in real numbers. 6-gauge wire is a 16 square millimeter cable. It says it here around 72 amps. So this is a bit on the small side, I must say. I would rather see 2 of these cables here going from the positive to our circuit breaker bottom. It's a silicon cable, so they can carry a bit more current. But man, these Chinese batteries, they're always saving on the cable size. Always. Well, here with the negative, they have actually used a 7-gauge wire, but 2 of them to go from the terminal, or to come from the BMS back to the terminal. And there's no actual square millimeter comparison to a 7-gauge wire. This is between 16 and 10 square millimeter. But at least we've got 2 of them. So this should give us at least a 100 amp current carrying capacity. So we maybe have 120 amps here on the negative side, but only 80, 90 here on the positive side. So there's a bit of an inconsistency. But guys, apart from that, I must say I'm a big fan of the Jaki batteries. They look amazing inside. They are well built. They're using these metal ducts here. All the cells are numbered, flexible bus bars, everything is checked. They have the spiral cable organizers around the cables. Nothing is hanging around. Everything is fixed cable ties there, around here. Perfect. I like it. Big fan of the build quality of these batteries. And they also provide you with these bus bars here, which go onto the outside terminals. So pretty much like this. And then you connect your battery over here on one side, and it doesn't cover your display. You can also turn it around on the other side here and have it more in the middle. You've got more access to the buttons here as well if you need to. But this one gives you a good clearance away from the buttons and the display. So this is actually a nice feature they include depending on your battery design and how you connect the batteries then to your system. So I have now connected the Jaki battery to our system. The breaker is still turned off while the other Jaki battery is charging at the moment from solar. So this one is 100% full. This sits on 50%, and we want to turn on the breaker now and see how much current is flowing into this battery. For that we have a look, 52.6. So we've got around 1.82 volt difference. Measuring the amps and turning on the battery. All right, we see 50 amps, 44, 38. Yeah, that's the same here. So there's not too much happening. The voltage difference was not high enough to trigger anything. I think it needs the overcurrent protection actually to trigger the current limiter, because we reached the 50 amps and the current limiter didn't kick in. It probably takes until tomorrow night until this battery is fully charged. But that's fine, we wait until then, and then we do the full discharge test and see what we get. Should be good. So I have now connected the Big Brother Jaki battery to our system, to the computer system first of all, to see what the standard parameters are like the battery comes with. And I've used the usual USB to RS232 adapter to connect to it. It uses the same software as the smaller battery. It's pretty much the same BMS. So what we have here is the P16S200A. So it's a 200 amp BMS, while in the smaller Jaki battery it's only 100 amp BMS. It looks like we have a newer software version here as well, 1.02, while in the smaller Jaki battery is a 1.00. But this could also be related to the larger 200 amp BMS here, so there might be a different firmware version anyway. All the other parameters, all the settings are pretty much the same. There's no new functionality with this BMS. So what I found here as well is the cell over voltage protection sits on 3.7 volts, which is a tiny bit too high for these cells. They should only be charged to 3.65. So make sure you change this one to 3.65. The balance threshold start voltage with 3.3 volts is a bit too low for my taste. So I would set this one to 3.45 volts. Because there's no reason to start balancing before 3.45 volts. Even at 3.4 volt, it is still a bit low. And if you charge this battery with a high current, you can easily reach 3.4 volts already, charging voltage. And then the balancer would start balancing, even there is nothing to balance. So you really want to get out of this knee, of this elbow, into the steep part of this curve, and then start balancing, not before that. Also, the PEC full charge voltage is set to 56 volts. This is also okay. I would set this one to 55.2 and set the PEC full charge current. This is basically our tail current, 1 amp, totally fine. The environmental temperatures are a bit high for my taste. I don't want to have this case on 75 degrees before I turn off charging or discharging. This is far too high, I think. You wouldn't touch the case anymore. You basically reach this temperature if you have a fire inside the case. That was also the reason I went with a crane on wheels, because I didn't want to attach anything to the garage roof and then would be stationary with the lifting options. Here I'm very flexible. And of course it is a lot more fun. I mean, who doesn't want to play with a crane? Okay, I have now stacked the two Jaki batteries on top of each other. So at the bottom the 230 amp and here's the 100 amp. Once the bottom one is fully charged, we can stack them together and then have a look at the communication as well, because this should just work. So I'm very keen to find out and see how this works. See, that's how compact it is when it's folded together. Guys, welcome back to the off-grid garage. It is now 3 days later and I have now fully charged the Big Brother Jaki battery. It took me a while, it took me a bit longer because we had this mush weather now for the last couple of days, which is not great for these solar panels here, which have charged the battery. But it was, let me show you. Yesterday, I made 17 kilowatt hours with the off-grid garage system here on the garage, carport and big shed. 17 kilowatt hours. I mean, that's crazy. We are in the middle of winter. And today it was not even 17 as well today. I tell you what, these clouds are perfect for my big battery here for the battery shelf, but really bad for the pull fence system because they are standing in full sun. And if it's cloudy, we are not getting much energy out of them. Anyway, we have now fully charged the battery to 55.2 volts. Well, actually, it was good to have some time before we start the discharge test now. And I used this time to get in touch with Jakiper and asked him some questions about the cabling, about the missing manual, the missing checklist, which we had in the smaller Jaki battery, and also about the numbering of the cells inside the battery. Not sure if you have realized, but they accidentally swapped the two lids with the numbering on it. So cell number 1 was at the positive and cell number 16 was at the negative. And usually counting starts from the negative terminal onwards. And I also found some weird stuff with the BMS, which was not working correctly, but this was entirely my fault because apparently I don't know how to operate a BMS. So and now I can actually continue this video and tell you all the secrets about the battery, the BMS. It turns out that this battery, I have taken off the smaller battery again because we want to do an infrared camera test when we do the discharge test later on. So this battery here is battery serial number 001. The 230 ampere hour battery is a brand new product for Jakiper. And apparently they have sent me the first one they have ever built. So this was a bit of a proof of concept battery. And they have also sent me photos now from the current production line. And they are now using a pair of 4-gauge wire. So a 4-gauge wire is about 25 millimeter, which is good for 100 amps. And then times 2 is 200 amps. Silicon cable can carry a bit more. So this is actually good and fits the circuit breaker of 250 amps then. So apparently this is the only battery which has only a 6-gauge wire on the positive terminal and 2 7-gauge wires on the negative terminal. Okay, and before I show you some more secrets with the Pace BMS they are using in the Jakiper battery, I want to start the discharge test because it is already 5 p.m. and it takes about 5 hours to fully discharge this battery into the Tesla now. So it will be 10 o'clock again until we can finish this test tonight. And I really want to get this up and running and then we can have a look at the BMS while the test is running. The power of the solar panels or the pull fence system today was just enough to push it over 55.2 volts in the afternoon. You can see the voltage is still at 55.5 volts. I'm not charging at all at the moment, so it's really saturated at this voltage. And the deviation is only 36 millivolt across all 16 cells. So this is one of the best top balanced battery I've ever received from anyone. That is really good. And I want to push this a little bit more. Let's see what happens if we go a little bit higher with the voltage. I have already attached my power supply. And if we change this, say, to 56 volts, which is then 3.5 per cell. And turn this on. We should see around 5 amps going into the battery, and voltage is now rising. And we can see the balancer is turning on here for cell number 15. So deviation is of course rising now, because now we're getting in the steeper part of this charge curve. Current is tapering off. I increased the voltage to 56.4 and also to 10 amps. Let's see, 10 amps. It's balancing only this one cell because this is the highest one, none of the other ones. It wants to bring this one down, but let the other ones charge. Deviation is still okay. It's 56 millivolt at 3.55 volts around. Cell number 16 is a bit low. It's the lowest. Oh no, it's changing actually. That's actually good. That's a good sign. If it changes from time to time. But see, the current is already tapering off, so the battery is actually saturated at this voltage. It sat there with the solar panel attached for a couple of hours, but didn't charge any higher then. Okay, 57 volts. Still cell number 15 is our highest. 3.6, alarm comes on, which didn't come on before. I'll tell you more in a second. Now cell number 14 is also balancing. Oh, there are more balances popping up now. 81 millivolt at 3.55 volts. Still charging with 4 amps. So this is actually pretty good. This is under 100 millivolt deviation, and I never had a battery so well top balanced here. And almost 100 millivolt deviation is actually pretty high. But I'm saying this because none of the cells is actually, there's not one cell limping behind all the other ones. They're all in the same ballpark, so this one will actually eventually balance out itself. There we go, 100 millivolt, and we are at 3.63 volt. But I would say this one is 100% saturated. This is how the battery comes to you, basically. Okay, I am resetting the smart shunt test. I have also set the battery capacity to 230 ampere hours this time, so it shows us actually the correct state of charge of the battery. And we should be good to go from this perspective. All right, I have driven down the Tesla to 20%, so there's enough capacity. And we turn on the Xia inverter. Let's see, oh yeah, fan comes on. Let's check the smart shunt as well. Smart shunt is working fine, discharging with 44 amps, 0.2 C discharge for the next 5 hours or so. And here people are always interested how the deviation looks like when the battery is full and gets discharged. So you can see the deviation going up and down a bit because we are using an inverter. And the inverter is not a constant load for the battery, because it replicates the sine wave of our AC output. And depending at what point the BMS measures the DC current, it could be very high or very low. So that's why we see the voltage going up and down as well. But this test is underway now, and before we finish the test at about 10:30 p.m., right, we want to have a look inside the Jaki battery with the infrared camera as well and see how the heat distribution looks like across the battery. When I was changing all these parameters here, I was playing around with the cell overvoltage alarm and cell overvoltage protection, and because the battery was not fully charged, I lowered these numbers here to 3.24 volts or something. And when I had a look at the real-time monitoring here, I could not see any alarm status here in the BMS at all. So I lowered the voltage to 3.1 volts for the alarm, and still no alarm showing, nothing. Couldn't get it to work. The same with the over voltage protection. So I set this one to 3.35. And while the solar was charging, I was far over 3.35, but the BMS didn't turn off. There was no protection, no alarm coming up at all, and I was really concerned. I said, well, it looks like this is not only battery 001, this one has also a faulty BMS, which I have never had before. I never had a faulty BMS in my life, never. Okay, apart from the ones I've blown up. So I went back to Jakiper and said, look, this is what's going on. I cannot get this BMS to give me an alarm or even a protection status. Sent them all the details, screenshots, videos, everything, and we couldn't figure it out. A few hours later, they came back to me and said, well, we found it, you haven't ticked the boxes in front of these groups. I had all these boxes here unticked, all these ones, and I had only this one ticked because I was working with the pack full charge voltage here for our CVL, DCL and CCL for the Victron system. So I was changing this parameter and see how the values actually then export to Victron. I said, well, I don't need to write all these parameters back. It is quicker if I just write these parameters of this block back here. This is not how it works. These checkboxes in the Pace BMS software here are actually function switches. Whenever you untick one of these boxes, it disables all these parameters for the BMS. And of course, I had this one disabled, but changed the value of my alarm and protection, but the BMS didn't do anything because all these 4 parameters here are disabled if this box is not ticked. This is very similar to the Seplos BMS where we have the function switches, and a lot of these function switches we can enable or disable certain functions in the BMS. And this is similarly done here, but only for a group. Yeah, this is the cell over voltage group, and I can enable or disable this whole function for all 4 of these settings or parameters. I didn't know that. Whenever you change something, make sure all your boxes are ticked here, unless for testing purposes you want to untick one of these boxes and disable all the settings belonging to this one group. So I think they have solved all my problems, all my complaints. They have addressed everything, came back to me very quickly. So far I cannot complain anything about this battery. We have to wait for the full discharge test though and see how much energy we actually get out of this battery. And we also want to have a quick look at paralleling this battery with the 100 ampere hour battery they have sent me earlier this year. Okay, I guess see you in a couple of hours when we are getting a little bit lower in energy. Okay, see you then. All right, and here we have a look on top of the battery. You can see 30 degrees. There's one bus bar here. This is all hand warm. It's actually nice in this cold garage. Okay, let's have a look at the BMS here. 29. This is our 6-gauge wire here. That looks all good. These are the flexible bus bars, 32 degrees. Yeah, this is all close to hand warm only. There's one a bit hotter here, this one. Okay, I'll probably check the screws later on and see if they have a different torque setting as the other ones. I mean, we are pulling only 50 amps, right? So it's not that bad. But yeah, it looks good. I was just editing a video inside and then looked on the remote control of the computer here and said 45 volts only. And I ran over here and then I forgot my mobile phone, had to go back, and well, we are down to 3% apparently. 2.7 volts is our lowest, cell number 9 at the moment, 100 millivolt deviation, and the smart shunt shows us 228.8 ampere hours pulled, which is 11.7 kilowatt hours. And this is exactly 11.776 kilowatt hours the battery should have. So we're almost there, guys. Amazing. These batteries are so well matched. So let's see if we can reach the 2.5 volts with one of the cells, or if the inverter shuts down before that, which I believe actually. 230 ampere hours. We have reached the rated capacity of this battery. 11.8 kilowatt hours, so we are a little bit over rated. So we're getting a low voltage alarm, cell under voltage alarm now for single cells, and we also have a pack under voltage alarm at 44 volts now. Pack under voltage, cell under voltage, and low state of charge. Wow. Just alarms. Battery is still going. Okay, 2.69 I can see here, and the highest voltage cell is 2.8. Look at this, 150 millivolt difference. Maximum 100 to 150 millivolt, depending where the BMS measures. Under 43 volts pack voltage, Almost all the cells are yellow now. They are all under 2.7 volts. And we have discharged 11.9 kilowatt hours. So more than the battery is rated for. All batteries in yellow except cell number 2, which is our highest. 42 volts. I'm not sure when the inverter shuts down, but this is incredible. 233 ampere hours discharged. 11.9. Do we see 12? No, we don't. The inverter is really low. 40. Now the inverter has turned off. Before the battery has turned off, guys. That is insane. I never had a test like this. Usually one of the batteries is really low in voltage and reaches then the 2.5 volts. Look at this, charging is still on, discharging is on. The battery is fully functional at 41 point something volts. So 233 ampere hours, 11.9 kilowatt hours. And the inverter has given up, not the battery. So we have charged 73 kilometers into the Tesla. So this gives me enough range for 2 days commuting. That is an incredible result for such a battery. I was not expecting this at all. The first smaller Jaki battery was okayish, it was good, but this one is pack under voltage, cell under voltage, and a low state of charge alarm for quite a while, and the battery just kept going. Oh, I've just seen the discharge actually took exactly 5 hours. Precise as a Swiss clock. Well guys, because it's already 10:30 in the PM now, I'll call it a night and I'll show you tomorrow how to connect these two batteries together to the Victron system or to your inverter. And then we do a final verdict on the Jaki Big Brother battery. Okay, here it comes. Here it comes. Here it comes. Okay, it's in place. So to connect these two batteries together, you obviously parallel them, so you connect your positive with your positive and negative with your negative. Either you daisy chain them or you connect them separately to your bus bar. Opinions are a bit mixed with this topic. I don't see a big problem with daisy chaining these batteries in a normal installation. If you have a very large installation with a lot of inverter power, it may be beneficial to connect these batteries separately to a bus bar, but here in the off-grid garage, I'm totally fine with daisy chaining them. And then we obviously have to connect the master battery via CAN to our inverter or Victron system in this case, or if you have an RS485 connection to your inverter. So we are using the usual battery, come on, focus. We are using the usual battery BMS CAN Type A cable from Victron. I'll link this down below. And we plug this into our CAN port here on the master battery, and the other end goes to our Victron system, either the Raspberry Pi with a CAN head or the Servo GX, directly to the BMS CAN bus. And then we have our RJ11 communication cable, RS232, which goes to our computer via an adapter. And then we have to program the master and the slave batteries with these dip switches. So if you have a single battery or a master battery, you have to put dip switch number 1 to on in the upper position, and all the other 3 dip switches are in the off position. We have just set the master to battery number 1, and now we have to set the slave battery to number 2. So we turn this one off and number 2 on. Now you can see the dip switch settings for the slave battery. This is now battery number 2. Number 1 the master, number 2 the slave. And then it is very easy to finalize the setup. You just need a short piece of patch cable. Plug this in either RS485 port at the master, and the other end goes into the RS485 port of the slave battery. And this is pretty much everything you need to do. We are in the remote console and go into settings. And then go all the way down to the Smart BMS. And here we go into details, and we should see both batteries now combined displayed in the system. Lowest cell is cell number 16 in the first battery in our master, and the highest cell is cell number 15 in the slave battery. You can see 2 battery modules are online. None of them is blocking charge or discharge. And the installed capacity is 460 ampere hours. Yeah, I have flagged this with Jaki already. This is of course not correct because we have a 230 ampere hour battery with a 100 ampere hour battery in parallel. But the master battery only knows there's another battery connected and assumes it has the same capacity as itself. So hopefully they can fix this with a firmware version in the next update. And then it shows the correct capacity of both batteries together. So there's no problem to combine different battery capacities, different BMSs, and connect them combined to your system, to your inverter or Victron system. It started raining. Okay guys, so far this testing of the brand new 230 ampere hour battery from Jaki. Guys, what can I say? An incredible battery. I was not expecting this. A very good quality build and workmanship. I very much like how it looks inside, very clean design. And with a 19-inch design, it makes it very easy to build up your tower of power. They all fit into a server rack and you can combine different battery capacities without any problems. I very much like the Pace BMS as well. It has very good features. It is easy to program. All important settings are very easy to understand. However, the Pace BMS does not show any DC load in your Victron system and adds it to the consumption. It only calculates the AC load of your inverter, but not the DC. So this would pretty much be the only negative point of this BMS, as well as it doesn't have Bluetooth. I would really like to see a Bluetooth application here for this BMS so I can quickly check it on my mobile phone, change a parameter here and there without having any cables and adapters connected to my computer. So a big advantage of the Pace BMS is that we can actually set a charge voltage and a tail current independent of the overvoltage protection parameters. So my friends, aufgepasst. Until the end of July 2023, this is another 24 days, 23 days or something, the first 3 people ordering are getting 8% discount on these batteries. 8% for the first three people. Everyone else afterwards is getting 5%. Unlimited customers. And you also get flat rate shipping here in Australia. So regardless if you order just 1 battery or 20, you're paying the same amount of shipping costs. Well, this is the deal they have offered and I'm passing on to you now. So forget about your next holiday or buying a new car. Take these 5 or 8% and get the Jaki battery. They're really good. Should really sell batteries, right? Now guys, I don't really care if you buy these batteries or not. I think they are really good. You have seen the video, you have seen the quality, you have seen the test results. And until the next video guys, when I show you the final design of my tilt mount on the roof and also share the ideas you have sent me. Well, until then, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. So, 3 people, 8%, everyone else afterwards, 5% until end of July 2023. Yep, that's what you get. And flat rate shipping. So, if you order 20 of these batteries, makes a difference. All the links are under the video.